Here in 47, I'm asked to calculate both of the mixed partial derivatives of a function and to verify that they're the same. So the mixed partial derivatives are the derivative with respect to x of the derivative with respect to y. So this says that the derivative with respect to y is going to act first. So I'm going to leave the derivative with respect to x sitting out to the left as I begin my work. The derivative with respect to y, then, is going to be the thing in this big parentheses. The derivative with respect to y, or any derivative, a natural log of something, is 1 over something times the derivative of that something. So 1 over 2x plus 3y, the argument of the log over there, times the derivative with respect to the very same variable of that argument. That's the chain rule. Right? The derivative of natural log of something is 1 over something times the derivative of something. Okay, so I will now continue calculating. I still have yet to do the calculation of the derivative with respect to x. I'm still in the middle of that, calculating the derivative with respect to y of all this. And I have a 1 over 2x plus 3y. And I am supposed to multiply that by the derivative with respect to y of 2x plus 3y. 2x is constant with respect to y, and 3y has a derivative of 3. So perhaps I could just squeeze that guy in up there. Good. Now I've got the derivative with respect to x left to perform of 1 over something. The derivative of 1 over something, that's the derivative of something to the negative first power. That's negative 1 times that thing to the negative second power. So let's see, 2x plus 3y squared, okay? I still got that 3 up there, and then following the chain rule, I still need to calculate the derivative with respect to x of that something, right? So again, the derivative of 1 over something is 1 over something squared times negative 1 times the derivative of that something, 2x plus 3y. And in the end, this comes out to, let's see, I'll put the negative up there, so I've got a negative 3 in the numerator for that. The 2x plus 3y squared is still down there, and then this factor over here, the derivative with respect to x of 2x, I'm sorry if my partials look like 2's. I swear it's been a lifelong struggle to get them to look different. The derivative with respect to x of 2x is simply 2, and the derivative with respect to x of 3y is 0. So I need another factor of 2. Or simplifying, negative 6 over 2x plus 3y squared. And similarly, if I reverse the order of the derivatives so that the partial derivative with respect to x acts first, the natural log of 2x plus 3y, okay, then I'll leave my derivative with respect to y over there, yet to be done. Let's see, this time I'm going to try to do a little bit more in my head. The derivative with respect to x of natural log of something is 1 over something, 2x plus 3y. Yes, y. Okay, so I don't know why I put that parentheses in there. Yeah, that doesn't need to be there at this point. I was just looking up there. Okay, anyway, the derivative with respect to x is what I'm calculating. 1 over something times the derivative of the argument. The derivative with respect to x of 2x plus 3y is 2. Alright, then I've got the derivative with respect to y left to do. I've got the derivative with respect to y of 1 over something, and that is 1 over something squared. 2x plus 3y squared will live down there in the bottom now. I need that negative sign that comes from taking the derivative of 1 over something. And I've still got my 2. And when I take the derivative with respect to y, the chain rule this time, the derivative of 1 over something times the derivative of something, the derivative of 2x plus 3y with respect to y is 3. So I get the same 2 times 3 for a negative 6. Good. Hey, they're the same. Okay, so here I slowed down, and maybe you found that easier to follow than down here. And yes, okay. You should be able to do it both ways, is what I want you to think about. Get out of here, hand. Sometimes in order to be careful in your calculation, you want to move, you want to write out, for instance, the chain rule here by saying 1 over the argument of natural log times the derivative of the argument of natural log. Okay, that's the way to really be careful. And then once you, let's say, I don't want to say once you get good. Sometimes when you're really good, that will go away. By the way, once you're in the practice, once you've practiced a lot for the sake of this class, some years later you will forget how to be really smooth and do a whole bunch of steps in your head. You should have also in your background the experience of writing things out slowly and carefully, like I did in this first calculation. Going up to there. Okay, the goal is not, again, the goal is not to be able to do this quickly in your head. You will lose that ability. It's nice to have that ability at least one point in your life. The goal is for you to be able to both do these things quickly now and to have a solid foundation that you can go back to when you lose that ability. End of rant. Thanks for tuning in.